My name is Pierre Roman. I'm a French-Canadian technical evangelist for Microsoft Canada. And I'm actually, you've probably heard that at every single session you've been today, but I'm super excited to be here for two specific reasons. This time last week, I was hooked up to machines in the hospitals, and I finally got the okay to travel just in time to make my flight, so I'm thrilled to be disconnected from all those machines. Second, it's -8 at my house, and there's half a foot of snow on my yard. So thank you for allowing us in your beautiful country. So if you're here, I already know a couple things about you. Either you have a disaster recovery that's not meeting your needs, or you don't have one and you want to figure out how to get one going. If you're expecting deep technical with gazillion scripts and lines of codes, not going to happen. Why? Because Microsoft, with Azure Site Recovery, we've worked really hard to make it simple. Because we know one thing. If your disaster recovery plan is too hard, it's not going to happen. Not too long ago, I did a architecture review for a customer up in Canada. I interviewed all of their ops folks and asked about their disaster recovery plan. And I'd say about 75% of the guys that I interviewed said they didn't have one. When I submitted my report, the Director General tore a strip off my back and said, "Your report is wrong, we have one." And I said, "Well, really?" And they turned around, picked up the big binder behind his desk, blew the dust off of it, put it on his desk, and says, "Yes, we have one, there it is." If the guys that are supposed to implement it don't know about it, it's just as good as if you don't have one at all. Shameless plug, if you need more info, I run a little blog called canitpro.net. With about 200,000 monthly viewers. So there's all of what we're going to see today is also documented in step-by-step series, illustrated on that blog. So if you're interested, go check it out. And of course, our hashtag CanITPro. Disasters, they happen. I did a quick search on the internet yesterday and found a few. Largest earthquake in 50 years in Melbourne. 80,000 lightning strikes. That should play a nice little trick with your electrical grid. Or tornadoes. In North America, because that's where I'm from and that's really what I know, the last big one that severely affected companies in the Northeast was Hurricane Sandy. And most people think that they have a disaster recovery site. So here has a disaster recovery site. Okay, not a whole lot. Is your disaster recovery site in the same city? Some say yes, okay. Typically, I've seen a lot of my customers, they'll have it like at the edge of town. One of my customers wasn't really thinking. They put it at the end of the runway at the airport. So if a plane misses the runway, they hit the data center. In New York, for example, a lot of companies had their disaster recovery point just outside city limit, thinking, okay, it's on a separate electrical grid, it's on a separate internet feed, so we'll be fine. Well, that's New York City, and that's Chicago, and that's the size of the storm that we had. That's 1,200 kilometers. Roughly. So putting a disaster recovery site in or close to where your main site is not normally a great idea. However, you have to balance that with the price of running black fiber between your environment and your disaster recovery site, because you want to be able to sync quickly. So there's always that. Where do I put it? How much is it going to cost me? So in New York, if that's the morning of, that's the entrance of the tunnel. So if you were going to work, that wasn't going to happen. But if you're co-locating or renting space out of other disaster recovery sites, that should work, right? The big guys, they're prepared, correct? Well, these are the top 10 co-located sites in the northeast of the US, the top 10 in terms of size and in terms of usage. The first 4 went down completely. The one in the middle was partially offline, was running off of diesel generators, and the last 3 stayed online with generators. So luckily, the Kardashians were off the internet for a few hours, because BuzzFeed and all those internet sites were actually located on some of those data centers. Disasters, you guys see them? These are some of the disasters that the pictures are not the exact ones, because the picture police asked me to replace them with license-free pictures. But in Canada, we have lots, in the West, we have lots of forest fires. Last summer, we had a group of MVPs that was dispatched to Saskatchewan because a city was at a risk of losing their data center, and of course, their backup was on site. So we went there with a bunch of MVPs, and overnight set up Azure Site Recovery, synced all of their critical system to the internet, and just waited to see whether or not the building was actually going to burn down or not. The busted down pylon, this actually is my hometown, where we had an ice storm that took out all of the electrical grids for 33 days. Oh, by the way, when they say indoor paint on the can, it really is indoor paint, because my house, all of the paint peeled off to all the walls. So disaster happened. It's not a matter of if, it's a matter of when. So we need to prepare, correct? Because if you look at it, the big data centers, the average is 3 outages per year. And if it's 3 outages of 5 minutes, it's not too bad, depending on your business. If you're manning a hospital with the critical care ward, well, maybe 3 minutes means that a couple people will die. Or if you're running a nuclear silo somewhere, well, you don't really want that 3 minutes of outage. The average time is 1.4 hours of downtime, and the average cost per outage, $690,000 US. So you say, okay, well, we're just going to build our own data center. Well, $21 million is the average data center for 8,000 square feet. That's not very big. Of course, you can co-locate, but then you don't end up having the security of having that somewhere replicated across multiple data centers in a geo-replicated fashion. So today we're going to look at availability on demand. What does that mean? We're going to look at protecting our physical machines with Azure. I was going to do protecting as well machines on VMware, but there's an excellent session that also looked at that during Ignite. So I will put the number of the session up on screen at the end, so you can check out either the session itself or the recording. Look at capacity planning, because of course when you're deciding which workload in your environment that you're going to protect, well, you got to build your infrastructure in consequence. If you're co-locating, and the last price I got for co-locating, so basically buying space in a rack, was $3,000 for a half rack per month. Well, in a half rack, if that's all you have, you really have to be careful as to which machine you are going to replicate to that area, because that's not a whole lot of space and a whole lot of resources. So capacity planning is good, is very important. And then we're going to look at migration using ASR. So, availability on demand. Availability on demand is not just about business recovery or business continuity and disaster recovery. It's about making sure that you have proper backup, that making sure that you have your long-term rotation, because be really aware that having a backup disaster recovery site is not long-time retention. You can't go to that site and say, I want the file that was modified last month. You're going to have to decide when you set up your environment how many, what are your RPOs, or your recovery point objectives. So do you want to recover any time in the last 24 hours in 15-minute increment, or you're going to we want to recover in the last month in every hour increment. All of these decisions will dictate in terms of how much capacity you need. Cloud migration, of course, if you're on premises, I know I owe $5 to the swear jar. On premises, if you want to scale, what do you need to do? Buy more hardware, buy more licenses, build that infrastructure so that you can scale to it. If you're planning an application that will use, well, I don't know, 1 million transactions per month, and suddenly some celebrity tweets about your service and it goes to 5 million transactions per month, you don't have the capacity, you're going to have a whole lot of unhappy customers. So availability on demand is there. Of course, dev tests. So if you're running a dev shop and you want to be able to spin up environments, spin them down, but I don't have to tell you all of that. The cloud is pretty clear. So business continuity. Typically, when I've spoken with large companies, or actually large, medium, and small companies, they always tells me that there are roadblocks. This is why I can't have a proper business recovery plan. My applications are too complex. It's not just the front end, it's the front end, it's the middleware, it's the database back end, it's AD, all of that put together. It's too complex for me to replicate all of that. It's too expensive. I've got too much data. I'd rather put my money on long-term retention. Time sensitive. Well, I can't lose an hour to do the failover. All these things. Well, Azure Site Recovery basically addresses that with a few things. Automate, automate, automate. I admit I am a lazy sysadmin, or I was. If I have to do something once, I'll do it manually. If I have to do something 20 times, I'll automate it. Just hit the button, sit back, wait for the scripts to finish. Integrate solutions with scale. That means don't just look at one-to-one. Look at one-to-one and then rate how you're going to grow this. All of that is covered in ASR, so Azure Site Recovery, and basically you roll over the roadblocks and you end up with a comprehensive business continuity plan. Oh, testable solution. Show of hands, some of you do have a business disaster recovery plan? Okay, keep your hands up. The ones that have tested it in the last 6 months, put your hands down. So, if you have not tested your business disaster recovery plan, how do you know it will work? You don't. It's the same with backup. I have a customer that was doing tape backup still, and they had a disaster and decided to restore from the tapes. So they pulled out the grandfather, father, son rotation, so they pulled out the last full backup and every incremental since, and they, at about tape number 9, it failed. So they couldn't restore that backup. So they went to the last one before that, and then that one failed as well. Then they went to the one before that. They ended up, the only backup that was able to restore was 6.5 weeks old, which is not bad if all you have is static data. But if you've got any kind of transactional system, if you've got any kind of actual role in your environment, 6 weeks worth of lost data, lost documents, lost transaction can cripple a company. So Azure Site Recovery gives you the opportunity to set it up, but also to test it on a regular basis without affecting your own environment. One of the nice features about that is it's heterogeneous. It's a hard word for a Frenchman to say, sorry. If you've got Linux environment, you got Windows environment, you don't have to plan 2 separate sets of disaster recovery. We will do that. If you're on VMware, if you're on Hyper-V, if you're on Hyper-V with Virtual Machine Manager, If you've got physical machine that you want to protect, ASR will do them all. Continuous data protection with near zero RPO. I'll show you a little bit later when we get to the demo. My environment, I have a lab in my house, and right now, I think the last time I looked, I was like 9 minutes RPO, which means I can recover, and all I'm going to lose is the last 9 minutes of transaction. Of course, there's not that many transactions that occur in my house. There's probably a lot of transactions that occur in your environments. However, I'm running this off of a residential DSL, and I was able to migrate, or not migrate, but replicate all my machines over the wire overnight. So, continuous data protection, multi-VM consistency. Very few of us have a system that is a single machine. We have AD, we have SQL, we have middleware, we have worker roles, we have a front end that connects to SQL. When you're backing it up, so for example, a SharePoint farm, front end, database, SharePoint server, you want to back it in the AD, you want to back it up all at the same time, but you also want to restore it at the same time and restore it or fail it over in a consistent manner, meaning they're all going to be at the same stage or at the same point in time. So you don't end up with the database that's newer than your SharePoint server or newer than the AD. So multi-VM consistency is built into the product. And the supported scenarios. You can, if you have your own site recovery center and you own it and you've got hardware in it, nobody ever will or shouldn't tell you to rip and replace. I know my marketing guys and especially my salespeople don't necessarily like it when I say that. If you've got resources, use them. So if you've got your own site, you can use Azure Site Recovery to manage the replication between your own sites, so site A to site B. You can do it between two data centers with VMware, between two data centers, a data center and with VMM and Azure, from a Hyper-V site, if that's all you're running, to Azure. There's multiple scenarios that are supported. And of course, security. Security is really important for the majority of folks, right? So if you've got your own VPN solution between you and the Azure in the cloud, you can use that. If you've got ExpressRoute, you can use that. If you don't have any, you can use the open internet. If you're using the open internet, you have to be aware that your data is encrypted. It's encrypted on site before it even hits the wire with a key that you control. So in terms of security, you're covered. It's a single-click failover for your plans. So when you look at the plan, if you've got a series of machines that need to be restored in a very specific order, then you make your plan, and then you can periodically test your plan with a single click. You go to the console, select the recovery plan that you're looking to test or fail over, hit the failover button, and it will fail over. Fail back to on-premises with VMware infrastructure, or fail back to on-premises with Hyper-V. That is the one thing that we do not know yet, is if you have a physical machine and you protect it in ASR, something happens and you fail it over, and it takes a few days for your original site to come back live, you can't fail back to that physical machine. So you'll have to fail it back to a virtual machine on your premises. So if you've got a Hyper-V server, you can restore to it or fail back to it. If you've got a VMware, you can fail back to that, but you cannot fail back to a physical machine. That kind of forces you into a migration path from physical to virtual. So the architecture is actually quite simple. Let me just build all of that. So you have your data centers. If you have multiple data centers, multiple sites, if you're protecting machines that are in a hoster location and you've got some on premises, that's okay. You can have multiple data centers. You need 3 machines minimum. The master target, which will collect the information and build the images of the replicated images that you, from your on-premises. The config server gives the process server, which is on-premises, which machine to protect, how to protect them, what kind of RPO am I looking at, and basically it sends that information, or it sits with that information and the process server goes and get it, because for anybody who's in security here, network security, no, you're going to make them very, very, very happy. No ports to open on your firewalls. It's a push thing. The process server will pull the config server to say, which machine should I protect? How often do I need to replicate them? And we'll take that information, collect the info, package it, encrypt it, compress it, send it out. Nothing ever gets pulled from your location. It always gets pushed out of your location. So very important, especially if you've got very rigid security guidelines in terms of firewall protection. So your process server, once it gets the information from the configuration server that says, I need to protect machine 1, 2, and 3, we'll ping those machines through WMI and file sharing services. We'll copy and install the, what's called the mobility client on those servers. Once the mobility client is installed, it'll start keeping track of all the actions on that server. So I/O and memory, read, writes, it keeps track of that, replicates that, sends it to the process server compiles it, compresses it, encrypts it, sends it to the master server rebuilds that image, which is why we end up with a lag. That's what your RPO are. So it's not real time. If any vendor tells you that they're doing real time, that should be a great solution, but it's really, really hard to achieve because you've got latency. The only way to do real time is, for example, if you have a SAN in your environment and you have a SAN in your business recovery site, have black fiber in between, your SANs will replicate to each other. So when you write to the first SAN, before you get confirmation that your transaction is complete, it'll wait, send it to the second SAN. Second SAN will write or complete the operation, send the confirmation to the first SAN, and the first SAN will then send you back that confirmation. I have seen an environment where they used that type of replication for an Exchange server. They introduced a 6-second lag every time you changed item in your inbox. So every time you clicked on an item on a mail message, you'd get the spinning donut for 6 seconds. Every time. That's not what we consider great end user experience. So very, that way is very unintrusive, and really there's no real impact to your users as well. So your mobility services, your process server, your master target server, and your config server is really all you need. Master and config sit in the cloud, process server sits on premises, and mobility service sits on any machine that you need to protect. And by the way, if you have any questions, just shout them out as we go. Don't wait till the end. Does that work? So let's set it up. And while I'm logging on, just wanted to give you a little update. Azure, the roadmap, I can't go into too many details. I'm under NDA. But we are looking at integrating ASR with the resource manager model and make it very, very simple. So they are going towards more of a disaster recovery as a service, where you won't have to set up all these individual boxes to get going. So if I look at my recovery services, my Azure portal, straightforward. In the data services, recovery services, you can set up two things, your backup vault or your site recovery vault. Eventually, the roadmap calls for them to be merged into one vault, but for now you have to treat them separately. So I go to site recovery vault, create, I'm going to give it a name, test ARC324, put it closest to your environment, so right now in Australia East, and I just hit the create vault, it goes away and creates the vault. Boom, done. Vault is created. That was pretty straightforward. I've got an environment here that has already been created, because if we wanted to go through the setup of each part today, it would take us probably about a couple hours just to set it up and the machines to spin them out, and we don't have that kind of time. So let's look at the vault that's already created. All right. Let's refresh that and see if it works. Isn't that I probably forgot to kill the chicken to the demo gods because it was working just before you guys walked in. There we go. So when you set up your vault, first thing you're going to do is you're going to go to the quick start page. It's pretty straightforward. It tells you one project, or step 1, step 2, step 3. Just follow the steps. You get to pick whether or not you're going to use any of those scenarios, so between on-premises and VMM and Azure. In this case, we've set up the environment as between on-premises with VMware or physical servers and Azure. So Azure is my site recovery, my recovery site. That way, the data is geo-replicated across multiple data centers, and that data, because it's replicated across multiple data centers, is subject to the SLAs that Microsoft has with your environment. So you go here and you deploy the configuration server. Asks you for a name, a username, password, the super secret Microsoft demo password. Just don't tell anyone. What kind of connectivity do you want to use? Public internet or VPN? In this case, I don't have a VPN set up between my environment and the cloud, so I'm just going to go with public internet. Which virtual network am I going to be targeting in Azure? Because you have to define that ahead of time. So if your network on premises has 5 main subnets where your servers are sitting, you want ahead of time to go in Azure and recreate that architecture so that you can fail over in the same controlled environment and the same type of environment. So if you've got your front-end servers in a DMZ, then create a DMZ. If you have your database servers and your AD in a back-end network with network security groups so that only the web server can connect to them, set it up that way. But you set it up ahead of time. Which subnet am I going to send it to? And give it an IP address as to what the server is going to be sitting in. Now I could click OK, and it would go. And what it does is it uses a image out of the gallery that Microsoft has that has the ASR client and information already configured, the number of drives required, the number of NICs required. All of that is already preset in the template. So this will just ask you a few questions, and it goes out and then passes that information to the Azure Fabric, and the Azure Fabric will then go out and create your virtual machine. So you end up with the config server that I have here. And regularly what you have to do on the server is update the files. And I'll show you how to do that in a little bit. So you create your server, your config server, number one. Number two, if I go back to my vault and my quick page, maybe I won't navigate away from that page for a while. Then the next step will be to create the master server. So the master server, like I said, is the server that sits in Azure and creates disks images from the information it gets from the process server. So in terms of capacity planning, and we're going to look at that a little bit later, you have to be very careful as to how many servers you're going to protect and how many volumes they each have. So yesterday when I was fiddling with my demo, I ran into my server, the size of my server, because I've used an A4 server as a limit of 15 volumes. So when I tried to protect another machine, it failed, telling me that the master target did not have enough slots available to protect it. Let's try this again. All right, while we wait, essentially, there we go. Essentially, once you have that, you can start deploying your master target. Again, same process. It'll ask you a few questions, what IP address to put, where to put it, which configuration server to connect it to, and then you can deploy it. Then you need to download the registration key. The registration key does a few things. Registration key is a file that is not empty, that has a few things. It's an XML file, really, that has the resource name, because it knows it's Azure Site Recovery, so it knows which vault you're going to be connecting to, and it has a management certificate to do the encryption, to make the link and make sure that you have authorized servers connecting to your master server. Once you've downloaded that information on your configuration server, you got to copy that file to that configuration server. And in the configuration server, once the client is finished installing, you go to Vault Registration, just browse to that file, and then register it. I'm not going to register it now because I've already registered it. Once it registers, it's going to pop up a little screen that's with a catchphrase that is generated, or a passphrase that is generated by that certificate. Make sure to copy it somewhere. You can always recover it later by using the gen passphrase -n command, and it will give me that key. So that's the key that will do the encryption between all of your machines. And you'll need that when you set up the process servers. So it's one thing to keep it in place. Now, as you can see in my environment, I'm actually protecting multiple machines. The AWS is not officially supported in terms of protection, but you can use Azure Site Recovery as a migration point or a migration tool. And we'll get into that a little bit later, but it's really, really cool. I have my VMware environment. I have a demo environment. I have an ASR environment that is sitting in another data center in Azure, so I can protect servers or VMs that are in US West with a disaster recovery site in US East, for example. Of course, if I've configured and architected my solution to take advantage of geo-replication and automatic failover, then I don't need to do that. Because of course, in Azure, if you architect the solution, if you architect a single point of failure, so if your web front end, for example, is only one instance, you don't actually qualify for the SLA. It's actually black and white in the SLA that your solution must be architected to take advantage of it. There was a saying about that, but I'm not going to say because it's a little bit more on the not politically correct side. And of course, I've got my SharePoint farm. So it doesn't matter whether or not, earlier in the slide where I had 2 different data centers, you can have 2 different data centers. 2 different data centers that have different domains, 2 data centers that have different environments. And you get to specify the domain name or local account name, because if it's you could protect a whole bunch of machines that are not connected to any domain, like in a work group type of environment. However, if you do that, there is a registry key to change, and I can't remember off the top of my head exactly where it is, but you just have to add this to the registry key. It's on canitpro.net. Go look it up. It's actually quite simple once you know, but it will allow or avoid when you try to deploy the agents to start protecting a machine to get the job failed. I'll show you what that looks like in a minute too. So once I've got this set up, I've got my accounts, and the reason we put the accounts there is if I add a new account, so I could a friendly name, so let's say this is ARC324. The username I'm going to use, if there are work groups that are different types or different names of the groups, but they all have the same admin, for example, I can say squiggle / admin or whatever the username is. So basically it's going to just append whichever domain / work group name is on the target machine and the name of the user. Put in a password, click OK. So what it's going to do, it's going to create the hash of the password and store that. So the password itself never gets stored, and never gets transmitted over wire. Because the last thing you want to do is what? Put your domain admin password in a script. So that's what the Azure Configuration Manager does. So now that we've got this done, and for sake of arguments, the master target has also been deployed. In the master target, the only thing it's going to ask is what is the IP address of the configuration server that I'm supposed to listen to. You can have multiple master servers to a single configuration server. You can have multiple config servers and multiple. It all depends on the amount of data, the amount of volumes that you're going to want to protect. If you use a DS14 or a DS4 machine size as your master server, then you'll end up with 32 slots or 32 volumes that you can protect. Typically, cheaper to do multiple A4s than a single DS4 in terms of pricings for the virtual machine itself, because you're actually paying for that virtual machine. It's Azure. It's pay as you go. Whatever you use, you pay for. What you don't use, you don't pay for. So I'll have to give it the IP address and the port number. In this case, because they're inside the same virtual network in Azure, it's still 443. I don't have to give it the endpoint. The endpoint is required because later when we deploy and install the process server, so the process server is just a zip file that you download. Once you've got it downloaded, there we go. Once you got it downloaded, did I clean that up? It's basically a zip file with two programs that you need to execute. One basically puts on the configuration for IIS, the Perl, a whole bunch of other tools that are required. And the second, oh, there it is. So the process installer is here. And of course, this is my own subscription, so I'm kind of underpowered on the machines, but they're coming out of my budget. So the first one, the TP, you install the Azure ASR configuration TP file. These will change regularly, so you can see that in the name of the file, there is the date code that's embedded into it. So you have to regularly check to see if there's updates to those files. And you can just download it and install it over top of it, and you can keep your environment set up that way. Once this is done, the second packages that you install will still stop and ask you, where is the internet connectivity? Because we already told it that we're going over public internet. So it wants to know what the real IP address is, not the internal. I don't have a VPN set up. If I had a VPN set up, I could just give it the internal IP address and keep everything in the family. In this case, I can't, so I have to go over public internet. So I have to give it the IP address and the configuration port. The configuration port is an endpoint in your VMs that has been mapped to 443 internally. So an endpoint is nothing more than port mapping between internet and the inside of a cloud service machine. And the passphrase that we got from the last machine. That's why I told you, when it generates it, copy it somewhere, write it down. Maybe not a good idea to copy it and then store it somewhere that can be viewed, because it is just text. Once that's done, hit the save button. It will go and connect itself to the vault and into the server section of your environment. I see the config server that we've set up, and because I've pointed all my other servers to it, you will show all the process servers, and right now there's 2 of them for me that are critical. So it gives you a very quick look at the health of your environment. So, whoa, so critical, why? So I'm gonna click on here and say, oh, that's my, my server farm, and like I told you earlier, I'm a little undersized in terms of the machine size that I used. So I'm right now pinning my processor at 100% and my memory usage at 83%. So it's telling me that I should just give it a little bit more oomph. But this is okay. The reason why it's doing that right now, it's because it's currently replicating a SharePoint farm. So it's taking 3 machines, compressing it, compacting it, encrypting it, and sending it over the wire. My AWS, it's stopped. I've actually shut down the machines in there because I actually got the bill. So I wanted to, I didn't want to be pay any more money. But so it does give you a very quick environment or a look at your environment. And then my master server, so I've got 2 master servers, and it'll tell you how many slots are used onto those servers. So you got to keep track of that, because if you get to 15 on those particular size of machines, if you get to 15, the next time you try to connect to a machine, it will fail. And we all love to look at event logs, right? So in this case, if I look at the jobs, it will keep up, and I'll just scan on failed, so show me all the ones that have failed. So I can see that, which one, that was the AD one that failed. See the error detail, and the error detail will give you an information as to why it failed. So in this particular one, I have a system restart that was pending. Basically, I spun up a machine, installed AD, it got its updates from Windows Update, installed them, and when there's a restart pending mode. You can't protect a machine that's in a restart pending mode or install the mobility service on that machine while it's in that mode. So we had to go, reboot it, try it again. And the way you try it again, very straightforward. You go into the protected items, because we're going to set that up in a minute. And in this one, all I had to do was remove it, because it would show up here with a red X, remove it, and then re-add it. So it would retry the push of the agent. And as you can see right now, And I started that at about 11 o'clock this morning. So on my SharePoint farm, 55% of my AD is replicated, 40% of my SQL Server is replicated, and 49% of my SharePoint server is replicated since 11 o'clock. So it actually goes fairly quickly. And of course, if you have a Linux environment, the requirement is your master server must be the same architecture as the server you're trying to protect. So if you're trying to protect Windows machine, your master server must be a Windows machine. If you want to protect Linux machine, a master server in your environment must be a Linux machine. And before anybody asks, currently, as of today, Red Hat is yet to be supported on there. Yes, we have announced that Red Hat will be supported, or they signed the agreement, but it still doesn't show up in our list of supported OS in the gallery. So basically, all of the Linux machines that are in our gallery, you can protect in your environment, because it uses the gold images that we have in our gallery to kind of help build the machines in the background. So we've got our environment, we've got our servers created. Next thing we want to do is set up our protection. And how we set up our protection, we create a protection group. So a new protection group, I can give it a name, ARC324. Which config server am I going to use, and what is my target? So if my environment was set up to do site to site, then it would ask me, it would, in the drop-down, would have Azure, but it will also have the other site that we've got defined. So in this case, we don't. Just go Azure, say yes. Here's the multi-connectivity, or the consistency, that we talked about. That means that when it does a restore of that protected items, or the protected group, it will make sure that all the servers in that group are at the same time stamp, pretty much. So your recovery point objectives will be synced up. And you can tell it what the threshold is. So 30 minutes is the maximum threshold that I want to have in terms of RPO. Of course, if I put that as a longer recovery point, then I end up storing a lot less data. And the way it stores the data, the initial replication takes a fair bit of time. So we looked at that about 50% total average in my farm in 3 hours. So by the end of the day, it'll be done. Once it's done, every time I tell it to have a recovery point objective, it sends the deltas. So what's changed since then? It takes the delta, Azure, the master server takes the delta, the previous complete image, and builds a whole new image. So you can pick any one of those images, and they're all complete images. It makes your recovery a lot quicker, because you don't have to recover one and then apply all the changes. They're already applied. And it makes it a lot safer. However, the more recovery point objective, or the shorter recovery point objective you have, so if I put that at 5 minutes, and I want the retention for 72 hours, I'm going to end up having every 5 minutes an image of that server for the last 72 hours. Imagine how much space that's going to use. You're paying for that space. Be careful with that. Too many people have gotten surprised with their Azure bill because they didn't take all these things into consideration, and I want to be completely transparent with you. So you set it up the way you want, and your application consistency and snapshot frequency. So how often does it actually go back and ensure that those machines are all synced up? So those 3 machines are synced up. Once you've got that protection group set up, I'm going to put that back down here. Set it up, and it creates the group. The group itself takes almost no time to set up. So if I look at a group that's already created, I've got 3 machines that are here. They're actually all protected, so they've all been replicated. And my RPO, 55 seconds, 54 seconds, and 1 minute. So the most I'm going to lose in terms of transaction on that WL1 server is 1 minute's worth of transaction. And that is my home lab, and that's over residential DSL. So if you've got a sizable pipe coming out of your data center, you can actually replicate and set a maximum RPO, but it will try to do as much as it can to make that gap very, very short. Now, if I look at one of those machines, because I want to be able to configure how it's going to behave once I convert it or once I fail it over. So that machine as a configuration in Azure will give me the opportunity to match the size or what size I would get. By default, it'll guess and give me something that is similar to what I have on premises. But you can change that. So if on premises you have 1 CPU and a gig of RAM, I can set it to an A10, which would be 8 cores and 56 gig of RAM. Is that something that's smart? Probably not in this particular case, but it gives you the opportunity to set it up whichever way you want. Plus, now I'm going to say, once I fail this over, where am I going to put it? Remember earlier when I said, make sure to configure your destination or your virtual network in Azure to be what you want it to be, or to as close as possible as your on-premises network, because that's where I'm going to say, well, that server is going to go on VLAN 1 and on this particular subnet, and when I save it, it saves it in the configuration of that virtual machine, which at this point is not a virtual machine. At this point, it's a disk image and a configuration file. So we're not actually paying for a VM at this point. We're just paying for the security of it. So right now it's still configuring that machine, but when it's done, and if I decide to fail it over, that'll be it. So we've got our group. In that group, I can add physical machines. I'm going to give it an IP address, so I'm going to give it another IP address from the machine that I'm sitting at home, 168.50.72. That one is my workload number 4, but that friendly name doesn't have to be tied to the machine you have. You could actually have a descriptive name of what that machine does, so that when you look at the list in your portal, it actually makes sense to you. So it is a friendly name. And then pick the operating system. And in this case, it did not offer me a Linux machine because I don't have a master target that is running Linux in my environment. Say next. What process server, so earlier when we looked at the graphics, we had process server in each of the on-premises locations that we have. So in this case, that one is my WL5 server, and I'm going to send it to the master 2 because my master 1 is running out of slots for my drives. Storage account, which has to be geo-replicated. Click next. Which account am I going to ask the configuration server to send to the process server when it asks for it? So that's why we've got them pre-configured. So the portal only read the friendly names that we put in associated with that password. It didn't actually read the password. So nowhere is that password sent back and forth. Click OK. It goes on, and now we have our environment. So you do that for all the servers. They all get replicated. Everything's fine. That's, at this point, we're ready to protect everything, but we're not nearly ready to actually deploy or fail it over. To fail it over, we need to set up a recovery plan. So we go into recovery plan. Right now I don't have one, so let's create one from scratch. 324. Which source server am I going to get? which entities am I going to protect, so I can mix and match from different groups. On this particular point, okay, is right now in the SharePoint protection group, I've got 0 because these machines are not finished syncing. We're still probably about 55% at this point. So let's go to my home lab. Number 4, also not available because it's not finished syncing, so it's never going to show it to you earlier. So let's pick the 3. And it builds the recovery plan. The recovery plan is a very powerful thing. If I go to my recovery plan, the basic recovery plan is going to look like this. All groups fail over, group 1 start. In group 1, I've got all the machines. If we have a SharePoint environment with AD, what's the first machine that needs to be deployed? The DC. What's the second machine that needs to be deployed? Your database. Third machine, your front end. So they need to be, if you were doing it by hand, that's the way you would do it, right? Why not configure it so that it happens exactly the way you want it every time? So there's no fumbling with the big binder to figure out what the steps are. You can put the steps in there. So we add a group. That's add 2 groups. Take machine 2, move it to group 2. Take machine 3, move it to group 3. So now, machine 1 will deploy or fail over. It's going to wait until machine 1 is done. If I need to act on it, so I can actually include in group 1 a script inside a side script in before group 1 or after. So let's say before. Can give it a name from my automation account. So Azure Automation, where you create your run books and you store them there. And then which run book to include. It's not liking that, but oh well. So I can include scripts in there. One of the scripts in a SharePoint farm, for example, would be group 3. After would be to where is it? It's not there. Oh, different account. Open port 80. It's pretty simple. Most people kind of, if it's not written down, I would have forgotten. See? I'm a lazy admin. I need it scripted. But after the end, you would want a PowerShell script that will go create that endpoint between your front-end machine in Azure, open the port 80 or the endpoint to the internet, and then possibly inside your script would go and update your DNS on the internet to now point to the new address. So you don't have to do anything. You can script it all. If there's something that you need to be done by compliance, for example, you can add a manual action. That manual action is basically just a stop. It won't come up and notify you that something needs to be done. It's just a stop. That you have to monitor your failover, and when it gets to that manual action, it just say waiting for input. Then you have to go in and do something. So we can include that manual action in our group and then save it. Once that group is saved, next thing we want to do is what? We've protected our machine, we've synced our machine, we've created the plan on how we're going to deploy them. It's all set, we've got all our scripts, we've got our manual action, everything is ready to go. What's the next thing to do? Test it. So we go back to our recovery plan, we pick the recovery plan we have, and we fail over. Do you want to confirm? Yes. Do I want the latest recovery point? Or if that protection group is a consistent, application consistent, turned on, which point is consistent across all the machines in that recovery plan. So I'm going to say latest application consistent. So it is aware of SharePoint. It is aware of most Windows workload. I'm trying to get an exhaustive list of all of the workloads that it's aware of, but it's changing rapidly. And now it's going out, and in the jobs, I will see or in progress, I will see that currently my job is going. So it's the exact recovery plan that we gave it. And it'll follow that and stop and be in progress for as long as it needs to go. And that, my friends, is basically how you set up Azure Site Recovery. I apologize if you expected deep, deep technical. We've worked really, really hard to make it not deep, deep hard. That way it's accessible for everyone, easy to set up, and actually fairly straightforward. So if we look at the actions that we did, we created our vaults, followed the quick start, set up our servers, our configuration master process, registered them, configured the protection, configured protecting specific virtual machine, created our recovery plan, and failed it over. Done. Wasn't that hard, was it? So the prerequisite for on-premises, for example, so the process server needs to be a 2012 R2 machine. It has to be on the same network and subnet as your source machines. So because it does use WMI, it does use file share process, which reminds me, where's my AD server? It's here. You will need to go in your policies for your subnet. That would help if I switch the screen. You will have to go in and change your inbound rule or add an inbound rule on your subnet to actually unlock the Windows firewall for two things. One is the file and print sharing, and the second one is the WMI, in and out on your domain. So I recommend you do that from group policies. Group policies apply every server that you want to be protected, included in that. That it opens up those ports only on the servers that need to be. I'm not a big fan of blanket situation where you open all the ports on all the machines for no apparent reason. Once that's done, and they're on the same subnet, your process server will be able to connect to them, copy the mobility service, install it, and get running. Of course, if you're doing VMware, minimum is the vSphere Client 5.5 for automatic discovery. And there's a great session that's I think it's tomorrow, but I can be wrong anyway, where it actually takes you, because it'll do auto discovery. And at this point, your process server basically just talks to your vSphere server and say, how many workloads are you currently running? vSphere will return the list of machines, and then you pick which ones they are, and then vSphere will put the agent on it and start replicating them. So your target servers and your config servers, again, they have to be in the same virtual network. Your storage account must be geo-redundant. Kind of defeats the purpose of putting it into a single data center when it's disaster recovery. Standard A3 configuration server and standard A4 or D4 for master target. Of course, you can always change that to fit your environment. So if you're like me and you go to your servers and your servers are critical because of their over tasks, then give them a little bit more information. Operating system, of course, has to be 64-bit for your source machine, so Windows 2008 R2 Service Pack 1 and above. No dynamic disk support, so if you have dynamic disks on your source machine, those disks will not
or will not convert as a dynamic disk, but they'll convert to a static. Of course, single or multiple NICs, that's fine. Linux machine, you can, the deck will be available. I'm just trying to get to the good parts here. For your capacity planning, so when you look at your master target, which is fairly important, your configuration servers is important. It'll connect up to 750 process servers or protected servers, but it's per volume. Everything is protected in terms of volume. So it's 750 slots really on the configuration server. And if every server that you're protecting has got 3 volumes, well, really you only have a capacity of 250 for that configuration server. So you can have multiple, depending on how many machines you're going to protect. And of course, your master target, what is important is the number of disks or slots that you're going to use. Keep track of that. If you've got a server that has 15 attached disks and you decide to protect that one, it's going to be 1 protected machine to 1 A4 master server. So you got to keep track. Storage accounts provision. That's when you start deciding whether or not you want to use standard storage, premium storage, because the capacity that you have to plan for there is a number of IOPS. So ASR guest-based replication is a 2.5 IOPS multiplier. So for every IOPS that's happening on your source server, 2.5 times that amount of IOPS is being used on the master server to actually rebuild that image. For every standard storage account, there's a maximum of 20,000 IOPS. So again, if you've got a server that is really, really, really busy, you may want to point it to its own master server. That's part of your disaster recovery pre-discovery. Because of course, we all know every server we have in our environment, what their IOPS profiles are and how many servers we have, how many volumes they have, and it's all pre-documented, right? That's what I thought. You guys are great. We're all rock stars, actually. Typically, in my experience, most people don't know how many disks they have across all their servers. And of course, I'm not saying you have to protect every server. The print server that's sitting in the corner that's servicing 4 printers may not need to be covered under your Azure Site Recovery protection plans. In terms of on-premises capacity, so that process server, it all depends on how many data change or the amount of change in all those protected servers that are connected to that process servers will dictate how much you need. So depending on 256 gig and above, or below, 2 CPUs and 4 gigs of RAM is more than adequate. You go 600 gigs to a terabyte of change in a day, then you want to make sure you've got at least 24 CPUs or 6 sockets and 24 terabytes of gigabytes of memory. And the drive on your, when you set up your protection server, your process server, sorry, you must attach a disk that's empty. It will format it and it will use that disk to stage and compress the information before it sends it out. So if you're pointing it to a disk that already has data, you're running the risk to losing that data. So create another one, another disk, empty, minimum of, I think it's 600 gigs. I typically just give it a terabyte drive in my virtual environment and away it goes, and it's happy with that. How much, you ask? Feel like an infomercial. It's actually pretty good in terms of price. If you're doing a site recovery to your own environment, so site A, Azure, site B, moving the data around, $16 a day, a month, sorry, not a day, $16 a month after the first 30 days. So the first 31 days are free, regardless of where you put your server. After that, $16 a month per instance protected, plus storage. We always pay for storage in Azure, in any cloud service. So if you've got 72 hours worth of recovery point at every 5 minutes, your storage costs are going to be high. If you've got 3 hours at every 20 minutes, then your storage costs are not going to be so high. So you keep that in mind when you set up your environment or when you design your environment. If you're using Azure as your site recovery, again, the first 31 days are free. $54 a month per instance. So if you're protecting 10 servers, that's $540 a month. Those are in Canadian dollars. You can go to the pricing calculator, change it to Australian dollars, but right now our dollars are pretty much at par. So that's roughly the same amount. I just forgot to update my slide this morning. Pretty good. Considering half a rack will go on your, well, I don't know what the prices are in Australia, but in Ottawa and Montreal, $3,000 a month for half a rack where you put your own hardware, co-located. Now, the abstract did say we were going to deal with migration. How many people are here for the migration part? Okay, one. That's just for you. What is migration? It's a failover without a failback. So everything we've looked at so far is your migration tool. If you've got physical servers on your premises that you want to migrate to Azure, AWS, you can set up a process server in your AWS network and use that to migrate off of AWS, off of VMware. Doesn't matter. It's a way to replicate a machine into the cloud, shut it down gracefully on premises, fail it over into the cloud, test it. Did it work? All my transaction there, am I good to go? Yes. Boom. Turn off that machine. You've now migrated your server. All you need to do once that's done is go back to your protected items and remove it from your protected items so that it doesn't try to replicate a machine that's turned off anymore. So in terms of business continuity and disaster recovery versus migration, uncontrolled versus controlled, because you decide when you're going to shut the first one down and fail over the second one. The first one requires a failback, so it's two ways. The second one is not. So in essence, you should be more than capable of migrating a workload to Azure within 31 days, right? At the very least, if it takes you a week to replicate the data, if it's a gigantic server, it takes you a week to replicate the data. Once you fail it over, everything works. If you do that within 31 days, and at the end, on the 30th day, you remove it from your protected items, that migration tool has now been free. Everybody likes free. We have, there are people in the industry that will try to sell you fairly expensive tools to do the exact same thing. So ASR is both in business continuity and disaster recovery tool, but it's also a very capable and very straightforward migration tool. Because before we add ASR, I think every time I did an Azure session, somebody would come up and say, I've got all of these physical machines, how do I migrate them? At the beginning, we didn't have a really good story, so the disk to VHD to convert them locally and then upload them to Azure in a storage account, and then from there create a virtual machine pointing at those disks and hope to God that they're all in sync. This takes care of it. So we've got both our migration and our disaster recovery. There are some free tools, and the deck will be available so you don't have to take pictures or write that down quickly. The 3 sessions that, and they did not put it in, or did they? Yes, they did. Related content. The 3 sessions that talk about ASR in either disaster recovery or migration fashion are store simple using Azure backup and Azure site recovery better together. And protect your VMware. How many people here are in a VMware environment? Okay, if you are looking at disaster recovery, you got to see that session. And migrating workload from Amazon to Azure seamlessly is the other one if you're trying to move over. My phone is now buzzing, which tells me that I am out of time. It's 3 o'clock on the dot. Thank you very much for spending that last hour and 15 minutes with me. My name is Pierre Roman, and if you want to chat some more, I will be in the speaker lounge after the session. Thank you very much. Oh, and I forgot the mandatory, please complete your evals. And remember, because I've had that before, 1 is bad. 4 or 5, because I don't know what the scale goes up this year, is good. Because I have had a 1, 1, 1, 1, 1, 1, 1, 1, 1. Fantastic session. Thank you very much. Let me know when you come back to town. Kind of hurts a little. So 1 is good. 1 is bad. 4 or 5 are good. Fill them out. Constructive criticism is always welcome. Thank you very much. Have a wonderful day.